functional safety. We are very much excited as well to walk you through functional safety and having an amazing SME subject matter expert like Priyank will be, running you through the idea of functional safety and its motivation to be there today in the complex automotive, electrical, and electronic systems as well. So in the meantime, for today's webinar, it will be really amazing to hear and what sets your interest to join the webinar today. Or to anyone, I think Vinayak, you can enable the option to unmute for anyone. If anybody would like to just set across your expectations for today's webinar, it would be really amazing to hear from you.
Yeah, hello. Am I audible?
Yeah, we can hear you, so you can go a little more louder.
This is Sheshak here, and I'm working in a Bosch as a base software developer. And for me, the functional safety is the kind of things I'm curious about to learn. And expectation from the class is to learn about the functional safety levels, and I need to take forward for my development, coding development. So that's my expectation.
Looks like I wasn't.
That's it from my side.
Thank you, Sesha, for your comments.
Yeah.
All right, then Vinayak, do we start?
Yeah, just give me a second.
Sorry, I think there's some internet issues. Great. I think a couple of minutes left to start the session. If anybody would like to just set your expectations and what you'd like to learn today in the webinar. So over to you. Anybody can unmute and just let us know what you like to learn as a part of today's webinar.
Hello, sir. Am I audible?
Hello, Muslim.
Yeah,
yes,
we can hear you.
Okay.
You can go ahead.
Yeah, sir. Today's time, the EV is one of the everyone has an expectation about that EV is to be run without any failure. So, in terms of the safety purpose, what will be the optimum utilization of it? So, my expectation is that you should put some focus on the EV, how to onboard that particular in our vehicle.
That's great. Good to connect and hear from you. So we look forward how best we can try to connect the dots, or if not, we try to see if we can form a webinar in the future just about these topics, maybe.
Great to hear, sir.
Awesome. So Vinayak, I think you're able to hear me well. Do you hear some noise from my side?
No, it's audible.
Okay, perfect. All right, I think we're about a minute to start the webinar. So if anybody still would like to come and just put across your expectations, it gives us a good motivation for us to start the webinar and with your inputs to the webinar to start today. So over to anyone who would like to just give an input and expectations that you have for today's webinar.
Hi Suraj, good evening. This is Mallikarjun.
Good evening, Mallikarjun.
So maybe some expectations here, like we know that we are following functional safety standard ISO 26262 in many of the vehicles, but I would like to understand, like, some of the vehicles I see that they are also following some other standards, maybe something like that. I wanted to understand, maybe that's expectation from this.
Okay, so what I understand from your question is that apart from functional safety, there are also other standards some of the OEMs are companies are trying to follow. So you would like to just get some lights on that, Is it just functional safety is the only standard, or is there any other standards also we could follow for, align to some of these requirements that we want to achieve as a functional safety, right?
Yeah, yes, right.
Okay, perfect. So awesome. So what a great day to start, and thanks a lot for everybody to barge in for today for the webinar. So I'm Suraj. I'm the founder and CEO of Decibels Lab, and we've been joined by Priyank Sharma, who is also the founder of Prakrit Energy. It is a startup based in Delhi, and not much to introduce about Decibels. So we are a platform enabling automotive-based training programs across the country and also across the globe as well. So it's privileged to join hands with Prakrit Energy to make this program possible, and also to create much more upcoming programs in the areas of functional safety. As definitely than me, Priyank is the right person to give you a depth and breadth of functional safety and its applications and its needs today for the complex environment. And for sure, if you see any automotive industry, maybe tire and suppliers, or even component suppliers, or maybe a OEM itself. So most of the jobs that we get today will have a requirement that functional safety as a skill, right? So because it has been so critical since that the automotive systems has gone so complex. We have a lot of electrical systems, we have a lot of electronic systems, we have a lot of software. So the amount that which was there in a vehicle in terms of electronics and electricals has increased a lot, and also in terms of the software as well. Henceforth, that it brings the requirement to bring a system that doesn't possibly set the customer into any hazardous situation. So henceforth, at this day, it is a day to start our first webinar series with Priyank and Prakrit Energy to set the journey to learn more about things like functional safety. And also in the upcoming days, we will launch larger programs that would be something like 3-day, very intensive programs in place. So with that as a notion to have this webinar in place, Priyank, over to you for the stage to enlighten us about the functional safety and its motive to bring us into the platform today for our participants. Over to you. Thank you.
Thank you, Suraj. Vinayak, you confirm you can hear me, right? And my screen as well?
Yes.
Perfect. Thank you. So thank you, Suraj, and it's awesome to be working with you. Hi, everyone. Thank you again very much for taking out time on a Saturday evening and getting together to learn about the very, very interesting topic of functional safety. It's clear that this is a very matured audience. You guys know pretty much a lot about the latest automotive technologies, and I'm really, really excited to have a discussion with you. So, of course, my name is Priyank. I'm the founder of Prakrit Energy and Technologies. We are a startup based out of Delhi. In the past, I've completed a master's from Pilani, and before that, I was working in DRDO for the LCA Tejas program as an undercarriage safety and reliability engineer. Before that, I worked on military UAVs. At Robert Bosch, I was working on ADAS and AD systems, braking systems. And as a part of my latest career move, before I started the company, I was working at ST Micro as a safety engineer for automotive semiconductors. And yeah, throughout my career, I've worked on safety critical systems, worked on their safety, worked on the reliability, making sure that they work when needed and they work in a way that the participants, their lives are not affected. So I've been talking about safety for a while now. Some of you know me, and at some point, I'm sure we've had discussions on this. So I was thinking what a good way I divide automotive technologies pre-COVID and post-COVID, and in a while you'll see why. So I'm confident that you all have heard of the ACES trend, the ACES trend in automotive technologies. A stands for automation or autonomous vehicles. C stands for connected vehicles. E stands for electrified vehicles or electric vehicles. And S stands for shared mobility. This trend, this terminology was quoted by, if I'm not wrong, by Forbes a while ago, and it has stuck on. And it will be a great way to talk about this now. So pre-COVID, we were seeing four trends, and automated, of course, means either full or partial automation. This automation is on the basis of the SAE levels, level 0 to level 5, 0 being no automation and L5 being full automation. And as per the part of ACES trends, we were expecting to have automated vehicles today. As a part of connected vehicles, we were expecting vehicle-to-vehicle communications to be mature, vehicle-to-infrastructure communications to be mature, and a lot other kinds of V2X, let's say, vehicle to X, where the vehicle could be communicating with any other entity in the traffic zone. Electrification means that due to, of course, the huge issue of climate change, there was a strong regulatory push to move into electric vehicles, and they can be classified in two ways: pure EVs that work on nothing but electrified powertrain, and hybrids, which have a mix of ICE, which is internal combustion engines, plus electric motors. The trend of shared mobility was essentially about having your vehicle either privately owned by or fleet owned, but anyone using it anytime they want. So it was sort of a vehicle as a service. So these were the trends that were defined a while ago. And let's see where we are today. Some things are achieved. So for example, in terms of automated vehicles, if you are in one of the few lucky cities in the US, you will be able to hail a cab. Let me just check the messages. Automated refers to ADAS, right? No, automated could mean full automation, and ADAS could mean advanced driver assistance systems. Right. So if you are in one of the lucky cities in the US, you can basically take out your phone and book a fully automated cab. It is state of the art. This is right now that you can get a robo taxi with no driver intervention whatsoever. And I think in that sense, we've achieved the A of the ACES trend. And of course, if you follow Tesla, just a couple of days back, they had a huge inauguration of their program for Cybercab. Cybercab was essentially a driverless pod in form of a taxi. Now, this is what they declared. I will not say anything further on the matter, but seems like automated driving is right here. The caveat being that it has been right here for a while. And those who follow the automated vehicle scenario, so I think you know what I'm talking about. In the area of connected vehicles, we've made only very marginal progress. Of course, a lot of us who drive cars know that our cars are connected. They're connected to our mobile phones. They're connected to our servers. So, for example, I drive a Tata Punch Electric. So my phone has all my vehicle data, and Tata has all my vehicle data all the time. So in that sense, we achieved that. What we don't have today as a solid use case is vehicle to vehicle communication or vehicle to infrastructure. I'll be happy if I'm if I'm wrong about this, but my research shows that there is no use case proven anywhere yet where this is a pretty mature technology. Reasons, of course, are many. We'll not go into that, but this is where we are today. Electrification is a roller coaster ride. At the moment, the EVs are penetrating our powertrains as we speak. The share of EVs in our total vehicle population are growing. On the same hand, we also see hybrids gaining a lot of demand. I'm sure if you visit a vehicle dealership, you'll see a lot of hybrid options now. So that's a good news. And on the shared side, I think this is where we achieved a lot of progress. Uber/Ola are already state of the art. Zoom car, of course, you can just fly to a city and take a car from there. So in that sense, shared mobility is a success. What it was envisioned a while ago, that nobody will own any vehicle, is not going to be realistic anytime soon. But shared mobility is a reality. So this is where we are today, and 2024. Now let's talk about challenges here. Just yesterday, it's incidental that I was researching for this presentation and I came across this. 2.5 million Tesla vehicles, which already have full self-driving feature have been brought under NHTSA or NHTSA investigation. NHTSA is the Highway Transportation Safety Authority, which makes sure that the vehicles plying on American roads are safe, and they make sure that all vehicles, if they are unsafe, they are not on the road, essentially. And they also conduct very, very heavy investigations. Just yesterday, seems like NHTSA has forced a recall for Tesla vehicles, 2.5 million. That's a big number. And this year alone, Waymo has seen a couple of voluntary recalls. Voluntary recalls are a good way to do it. And Waymo has been a champion in terms of automated driving safety. But I think all of us can agree that there are challenges that remain in the field of automated driving. For connected, the biggest challenge is still we don't have a use case as far as, like I said before, my research shows. As someone before, I think it was Shesha who indicated that battery safety is a huge issue for electric cars. I personally know people who love the idea of EVs, but they are scared because of the very, very energy dense lithium-ion batteries in their cars. I will be lying if I said even I'm not worried all the time. Not all the time, sometimes, especially if I'm driving my car on a very, very hot day. And yeah, that's a fact. There's no denying that. And of course, for EVs, the cost of the vehicle ownership, the charging infrastructure, the disposal of lithium batteries, the big question mark that are EVs really environment friendly, they still remain. Shared, of course, like I said, not many challenges out there. But essentially, what I wanted to talk about is that safety remains a key and emerging challenge to automotive technology adoption. A lot of technologies take a lot of time to breach our roads simply because they don't reach the level of safety which we expect a vehicle to. So with that, let's look at what a modern automobile looks like. I'm sure that a lot of you, especially working in the field of vehicle software design, vehicle hardware design, tier ones, OEMs, they're aware of this, but I want to really, really emphasize the scale of what we're talking about here. If you talk about a small aircraft today that you can potentially fly, the number of lines of code it has is several orders of magnitude lower than a car would have. If you're talking about 100 million for cars, if I'm not wrong, 50 million for satellites, 10 for airliners, 1 for small aircraft. Essentially, what we're trying to say here is that an automobile, the amount of software that goes into an automobile is extremely, extremely high compared to other technology areas. Talking about some specific numbers, like I said, 100 million lines of code for software. An average car has about 2,000 plus semiconductor pieces. And more features you add in, the more number of semiconductor increases. And folks working in the field of semiconductor knows that the failure rate of a semiconductor is proportional to its size. And so the more semiconductor you squeeze into a car, the more the reliability goes down. Hundreds of features today are enabled by electronics. 99% of innovations that happen in automotive technology are enabled by electronics. That is a staggering figure compared to just 30 to 40 years ago when almost none of the innovations were electronics based. The amount of electronics in a car, of course, hardware plus software, takes about 30% of the total vehicle cost, which is a huge number starting from zero again, just a few decades ago. And the total market at this point is 400 billion. This is not the automotive market. This is just automotive electronics market. Of course, hardware plus software. And so you see the big market opportunity here, which a lot of forward-looking companies target. Of course, it's obvious that anyone will talk about safety is important, but how do we justify the pricing of it? Now, I will talk about economics first. I will not be touching the legal and ethical ones because they're outside the scope at the moment. But the economics of safety alone justify the cost spent on functional safety. I'm quoting a 2018 figure because this was the worst figure ever recorded. But in 2018, 20 billion US dollars were essentially wasted in the American automobile market on vehicle recalls, safety recalls. And just to get a reference here, the total market cap of Tata is 45 billion. Imagine the amount of wastage because of vehicle recalls. And the biggest use case I saw per vehicle was $11,000, a Hyundai EV. What I'm trying to say here is that to recall and fix every Hyundai EV, $11,000 was spent by the company to fix the cars which they have already sold. So in both areas, you see that either due to total vehicle safety recalls or due to the recall per vehicle cost, investing in safety makes a lot of sense. When a company conducts a recall, what do they spend on essentially? The biggest cost, of course, is material cost. When I say material cost, it will also include the amount of software to be rewritten to fix the errors. And so EE/E meaning electrical and electronics cost and mechanical costs. And this is the biggest chunk of spend. But of course, the reputational damage. I mean, I consciously try not to buy vehicles of a certain kind or not to fly aircraft of a certain kind because I've seen some safety related issues there. And so a reputational damage is a big issue if it comes to vehicle recalls. A rival consolidation meanwhile happens because when a company goes down in its safety perception, it allows other companies to capitalize on it. I'm sure we can think of examples like that. And opportunity cost, the amount of time taken to address a recall is wasted because that amount of money and manpower could be spent on other kind of innovations. So I'm sure folks in this audience very well agree with me that it's always great to invest in safety. And with that, let's try to understand what function safety is. Of course, someone quoted ISO 26262 before, and so this is the most accepted definition of the term functional safety. It's the absence of unreasonable risk due to hazards caused by malfunctioning behavior of EE systems. We all know this definition. What does it mean? Absence of unreasonable risk. The keyword here being unreasonable. We could have just said it as absence of risk. But every day you step out of the house, you are exposing yourself to at least some kind of risk. The keyword here being unreasonable. The vehicles are a commercial market, and they only need to achieve a certain level of safety to be sold as well, because the automakers need to make money. So absence of unreasonable risk is what we should strive for. Due to hazards caused by malfunctioning behavior of EE systems. The malfunctioning, of course, could be interpreted in various ways, faults, failures, errors, but it's a generic definition here. And so this is the commonly accepted definition of functional safety.
Yeah, hi. Can you hear me?
Yes.
Yeah, actually, I have one query. If Tier 1 suppliers are the most affected one during the vehicle recall because they, like a Bosch, Conti, or some other Tier 1 suppliers? Because I have these questions long back, but I don't get much answer on this. Now, did OEM or Tier 1 will affected more on that
I
vehicle?
I think it depends on case-to-case basis. It could be anyone. It could be even tier 2 if it comes to that. Could be tier 3 if it comes to that. So the liability has to be established, and the entity on which the liability is established, I think that would be the entity that would pay the most for the recall.
Yeah.
Again, if you can bring up a use case, specific one, then I'm happy to research and brainstorm with you on that topic.
Yeah, sure. Um,
Okay.
do you think there will be a recent issue with the BMW that they will recall the vehicle that made by Conti? Do you hear about the news?
Okay.
But I researched about this, but I can't get much information, technical information. That's my where it will get affected, like vehicle dynamics or and powertrain systems.
I think
So,
to answer that question, a lot of I'd have to read the news myself as well. But I think
yeah,
it's not
sure,
an
sure.
easy one to answer without more information. But
We can
I,
have it later also.
yeah, but all I'll say on the matter is that it could be anyone. It doesn't necessarily have to be the tier 1. It depends on the specific case of what the situation is of around a recall.
Yeah, because I'll hear that the Taiwan will also have a provide a warranties for the software and um, hardware specific things. So they need to pay more cost to the OEMs for a reputation cost and a warranty cost as well. So that's why I asked this question.
But
So
again, see, in that aspect, even contractual obligations matter. We do not know what the contractual obligations were between the
yeah,
said OEM and the said tier one. So again, it would require a lot of inside knowledge to comment on who it affects more. But in
yeah,
theory, at least, it could be anyone in that sense.
yeah, yeah. Thanks for your answer and sorry I interrupted with you.
It's okay. It's okay. Totally fine.
Thank you. Thank
All
you.
right. Yeah. Thank you for your question. Right. So we love the word ASIL, but I will not be talking about ASIL today. I want to talk about what the method is for risk assessment of for automotive hazards. Um, Simply speaking, if I take away the automotive context, let's say in terms of aerospace or space systems, severity and probability of occurrence are the two factors that affect the perception of risk. But the big difference in vehicles is that a human can actually intervene and control the situation, which may not be the case for a space-based system or an aerospace-based system. So for automotive context, three parameters affect the hazard rating for a specific malfunction: severity, exposure, controllability. I guess we've heard them a lot of times. So I'll not go into a lot of details, but I assure you that the matter is very, very complicated in all of them. Of course, the definition could here simply say that the severity rating is the degree of injury to the traffic participant. Now, you have to begin with the idea that let's say we start with the system A, and let us assume that system A, which is installed in a vehicle, has failed. Now, given the fact that system A has malfunctioned, what is the degree of injury to the traffic participant? And that's how you arrive at the S rating for that specific malfunction. So S0 being the lowest, S3 being the highest. Exposure. And this is where the highest complexity lies. Exposure means that given a malfunction has already occurred, what is the likelihood of a situation becoming hazardous? Think about a failure in your car that does not really immediately affect you. For example, if you lose your brakes, that's definitely disastrous immediately. So no questions asked. But there are some systems where the failures could not be affecting immediately, but they only manifest themselves in a certain scenario. A great example of that being airbag. Um, the airbag not working is less safety critical than the airbag working unintendedly. Think about it. But what I'm trying to say here is that if the airbag on your car doesn't work, which means that it is not um, exploding when it's needed to, it is not immediately hazardous. It becomes hazardous only when the vehicle enters an accident. In that case, the exposure for this will not be E4. It will be lesser than that. So exposure is the one where a lot of confusion lies. But essentially, exposure is the likelihood of a situation becoming hazardous given a malfunction has occurred. Again, E4 to E0 to E4, E0 being the least, E4 being the highest. And controllability. And this one is about how certain humans will react to a situation given that the malfunction has occurred. So for example, this is my favorite question. I will not be asking your responses, but it's a question for you, and think to yourself. What happens if somehow the main brakes on your car fail? Now, I repeat the question. What happens if you're informed that the brakes have failed? Think about what you would do. I'll probably give a couple of seconds. Main brakes have failed, like the brake pedal. If your answer is, what can I do? At most, I might try to steer. At most, I might try to steer. At most, I might try to take my foot off the accelerator. But what else can I do, really? Um, if your answer is that, then that's one set of answers. The second set of answers is that I would put the parking brake. Now, of course, I'm not going to take a poll here, but if you answered the first one, then I would suggest you seriously read the instruction manual of your car, because even I did not know this until I actually read the instruction manual of my car very, very deeply. And that's the point here. How many percentage of drivers are going to be able to react smartly and pull on the parking brake if the main brakes fail? And you'll be surprised on how many things as a driver you can do in the event of failures if you read the instruction manual properly. So controllability means that given a malfunction has occurred, what is the ability of a driver to avoid harm? And this is a quantitative number, not a qualitative one. So the percentile of drivers that will avoid an accident directly correlates with the controllability rating. C0 being the least, and which means the situation is the least hazardous, and C3 being the highest, that there is absolutely no way of controlling whatever happens. And if you answer the one about parking brake, it's expected that 100 percentile drivers do that, because it's expected that all the drivers on the road actually read the instruction manual of their cars. And if you don't read the instruction manual of your car, the liability is not on the car, but on you. I am sure we agree with the principle, but how many of us actually have read the complete instruction manual? I think it's a question for introspection. But essentially, that's how you basically come up with 3 ratings, S, E, and C. The 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 combination of S, E, and C ultimately result in an ASIL, and I will not be talking about ASIL in this session. All right, now given that certain systems are subject to malfunctions and which will lead to making a situation hazardous, and thus we need to achieve a certain level of ASIL development, how do we tailor our processes? And so if you look at ISO 26062, this is a very, very scary looking gist of the various steps. And this is the development process embedded with safety. And there are 12 parts of, sorry, 11 parts. There are 12 parts. I don't know. So there are 12 parts of the ISO 26262. Part 1 being vocabulary, part 2 management. There's 3, there's 4, there's 5, 6, 7, 8, 9, 10, 11, 12. Here's the 12th one for motorcycles. Depending on which company you work for, which product you work for, which project you work for, you might be working on a subset of the safety development lifecycle. I have personally worked on part 4, part 5, part 6, part 11, and of course, a couple of other part 9s and part 8s. But of course, depending on your specific project, you'll be working on a specific part. And I will not leave this very scary looking picture for too long. Let me come to a better looking picture. This is what a modern development lifecycle looks like. And this is not software, this is not hardware, this is a generic description of what what a process with embedded safety looks like. But this is very, very top level. But essentially, the kind of safety activities involved at the specification stage, where you define the spec of a product. The safety related activity that you must carry on here is the HARA, the hazard analysis and risk assessment, which will ultimately result in determination of an ASIL for the specific requirement of the spec. Depending on the spec, you begin with the high level design. And at this stage, it is recommended you carry out a safety concept. Now, some of you already know the difference between functional safety concept and technical safety concept. But for the ones who don't, a functional safety concept is a bit at a higher hierarchical level, and a technical safety concept is a bit lower, which means it defines technical requirements. But essentially, just to give a gist of it, you must have a safety concept accompanying the high level design. As a part of detailed design next, you must carry on the safety analysis to justify the spec as well as the overall safety planning of the project. And of course, on the right side of the V cycle, safety verification, safety validation, safety assessment. And all of this is managed via safety planning and management. Now, of course, this is very, very generic. But what's interesting is that you can apply this similar fundamental principles across various industries. You could be a software developer, you could be a ECU developer, you could be a VLSI professional, I mean, semiconductor professional. You could be a system designer. And this life cycle will apply in most places. Now, of course, some steps are skippable, but the principle remains robust, that these are the major activities you must carry out. And this is a very, very condensed form of the ISO across all parts. And depending on your specialization and your project and your product, like I said before, you might be working on a very, very specific part of the life cycle. I see a lot of interest in safety analysis, which is why I wanted to briefly talk about all of them. I'll be happy to talk about specific questions if you have, but let's begin with the FMEA. FMEA being the oldest, the most exhaustive, the most time-taking, the most annoying in my opinion, the failure mode effects analysis. It essentially was a part of a military standard, MIL standard 1629. This is back in World War II era, which was then adopted by the US Air Force, which was then adopted by NASA, which then became an industry standard across automotive as well. FMEAs are bottom up, they're inductive. What does that mean? Bottom up means that you strip open the bill of material of a component, you pick up each and every component individually, determine its failure modes, determine its failure causes, determine its root causes, determine its probability of occurrence, and so on. And then you form this complete analysis for each and every element in the product. It's an exhaustive analysis, takes the highest amount of time. So performing FMEA should be done very smartly. It is important to do it, and it is very, very important in the certification of a product. The other analysis I did not mention here is the FMEDA, which is more specific for hardware professionals like Part 5 professionals and Part 11 professionals. FMEDA is including diagnostics analysis, which means that if you add a safety mechanism for a specific failure mode, what is the likelihood that that specific safety mechanism would prevent that failure from becoming hazardous? I did not say prevent the failure from happening. I said preventing the failure from becoming hazardous. And that's a big difference here. And FMEDA estimates the percentage of success of the safety concept, if I have to keep it short. Quality analysis is the highest results in the shortest amount of time kind of analysis. It's again started from space applications, went on to nuclear, then adopted by aerospace. And again, it's a very, very solid automotive analysis. It's top down. So here you're picking up a bill of material and stripping off each and every element to come up with the failure modes. Here, you start with the safety goals. And this is what makes FTAs so efficient. You directly begin from what is the idea of safety at the top level, so safety goals, and then you come up with the failure rates. So it's a quantitative analysis. It's a quantitative prediction of the violation of safety goal based on unit failure rates. So let's say the failure is happening at the OEM level and you're a tier 2 supplier. You must be able to predict what your base failure rates are as a tier 2 supplier for the OEM to estimate what is the failure rate for their top level safety goal. And that's what makes it so efficient. You directly come to the meat of the matter. DFAs are dependent failure analysis. And if I can be candid, this is my favorite analysis because this requires a lot of critical thinking. And folks who've done DFAs, I'm sure you agree that the DFAs require a very different style of thinking. It is not linear. It requires non-linear thinking. DFAs are exploring the occurrence of cascading faults and common cause faults, to keep it short. What are cascading faults? Cascading faults are the kinds of faults which happen in one element, but they lead to failure of another element at the same level. So imagine a fishbone diagram, one failure on one element leading to failure of the same level. Examples to give are a little difficult right now, but you can imagine that element A and element B are performing their respective features, but somehow the failure of element A is causing the failure of element B, which doesn't look like they're connected, but actually they're connected in some sort of way. This connection is sometimes called a DFI, dependent failure initiator. And this DFI might be visible or might be invisible. And the key to unlock cascading faults is to identify those DFIs. And then there are common cause faults, as the name suggests. You look at two elements, you look at the failures of the two elements, and the two failures look like they're independent, but actually they're not. They're caused due to the same failure of an element which is at a lower level. So here I want to take you back to class 11th, which is about Bayes' theorem, conditional probability. Two failures which look like independent events are actually not because they are conditional to each other. So in case element A fails, the probability of failure of other elements increases. So DFAs, you can also do it qualitatively. but it makes more sense to do it quantitatively. And this requires some knowledge on probabilities. And with that, that's my time. As Suraj mentioned before, there's lots in store. In the next session, I want to talk about some certain and specific examples of HARA and ACIL determination. I want to talk about the topics of FTTI, FDTI, FHTI, FTTI being a fault tolerant time interval, FDTI meaning fault detection time interval, and FHTI meaning fault handling time interval. How are they three related to each other, and how do they influence the system design? That's very interesting. I want to assess controllability, which I touched upon a little, but I want to do it a lot more in detail with certain specific examples. I want to talk about semiconductor function safety, which is, in my opinion, a very, very complicated topic, and it requires a lot of time to be spent on it. And some words on diagnostic coverage as well. And Vinayak, I hope we can also open the floor for suggestions from the participants that if they want to, hear us talk about some specific examples in the next session.
Yeah, we have a form for that, feedback form. We can share that.
Perfect. So please, all, you can use the feedback form and tell us exactly what you'd like to, hear about in next session. And with that, that's my time. Thank you very much for, spending time with me on Saturday evening. I think we can open the floor for questions, if there are any.
Hello. Hi, all. Hi.
Hello.
Yeah, first of all, it was a wonderful session. Thank you so much.
Thank
Yeah,
you very much.
I have a question on it's a general question, maybe. So you might have heard the Fiscus failure in terms of mainly, I would say, functional safety.
Mhm.
For example, recently they had this software glitches in ocean vehicles. They had to recall them, right? And also there were some kind of BMS issues in late 2008 or 9, I guess. So despite having a functional safety team and software developers there, uh, what do you think that might have been gone wrong there? Because they also have the functional safety. Yeah, it's a very general question. Yeah.
But of course, I'll be giving my personal opinion here because I don't want to quote anyone here. My personal opinion is a company culture. I mean, I also spend a lot of time on the company culture aspect. And again, I don't want to take names, but we all know companies who underspend on safety, slash, they don't invest enough in safety, slash, they don't respect safety. And company culture is very, very important. I cannot comment on Fisker because I don't know what exactly went wrong in their internal doings. But the company culture and the attitude towards customers, and by extension, the safety of customers, is what affects and influences product development. Um, if you're a company that respects customers' safety a lot, I can take some very good examples like Volvo or Mercedes. I'm happy to take these examples because they've proven their meat in the matter. I would also respect Robert Bosch a lot in that sense, because I worked there. All I'm trying to say here is that company culture influences this a lot. If you're driven by corporate earnings very strongly, then you will not be able to invest in safety too much. And again, that's my personal opinion.
And the boiler as well.
Yeah, thanks. Completely agree with you. Yeah, thank you.
Thank you. Anyone else? Any questions or any ideas or any other things that you want to talk about?
Yeah, is it possible to get this recording?
Vinayak, I'm sorry, you're asking about the recording of the session, right?
Yeah, yeah.
Vinayak, I think we can do that or not. I don't know.
Sorry, voice got broke. Can you repeat?
I think the question was on the recording of the meeting. Will that be provided or?
PPT
Okay.
is it, of course.
Yeah, tomorrow, maybe by Monday evening, we'll be uploading it to our YouTube channel. They can view it from there. I'll be sharing the channel link as well.
Yeah, yeah. Thank you.
Yeah.
Thank you. Mallikarjun, I'll take your questions which are on the chat already. Very interesting one. How does functional safety differ from general safety in automotive systems? I think functional safety is a subset of safety. There are lots of safety, crash safety, for example. But functional safety specifically talks about EE systems, electrical and electronic systems, and the scope is limited. So we don't talk about the aspects of vehicle crashes, for example, in terms of the robustness of the structure. We only talk about those failures which are due to EE systems. So I think that's where it's different. If you're talking about different in terms of addressing it, then I want to go back to this slide because this is a very interesting question. Um, for EE systems, controllability plays a big role for ASIL determination. And so that's only because humans have the ability to control vehicle related situations. Instead, there are some other kinds of safety where human controllability is not a factor. And so I assume that if you are talking about crash safety, I think the controllability would play a lesser role there. That's what I can come up with right now. But again, it depends on the specific safety standard followed there. Next question from Mallikarjun. How do you ensure compliance with global function safety standards for EV components? I think easy answer, follow the standards. Of course, following the standard is easier said than done. It's very expensive. But the best answer to that would be the standards are there. I don't know, Mallikarjun, if your question is talking about something else, if I misinterpreted.
Yeah, so maybe just a question like while I'm working on BMS, so I hear that apart from ISO 2626, there are some other standards the supplier is following. So just I wanted to ensure like what is that something we need to follow? Is it the ISO 26262 or other standards also accepted? Or it depends upon the market?
No, there are plenty of safety standards. So if I talk about ISO in context of electrical vehicles, it will focus on the failures of the BMS ECU leading to thermal runaway, for example. But then the handling of the chemical aspects of the batteries themselves would require a different kind of safety standard. So chemical safety would be completely something else. Similarly, in airbag design, we only talk about from the context of ISO 26262, the part of E system which contributes to actuation of an airbag, but the actual explosion of the airbag is of a different safety standard. The amount of pressure generated due to combustion of certain chemicals inside, that would follow a different kind of safety standard. And again, if I talk about my experience at DRDO, for example, if you talk about, you know, emergency evacuation systems, the ejection seats, what we call them, they follow a different kind of safety standard altogether, depending on the which it's a single use system, right? So there's no aspect of reliability or failure rates. It must never fail, period. So depending on the product, the process, the project, the safety standard applicable would be different. This session and this standard of ISO 2262 focuses on EE systems leading to safety hazards.
Yeah, got it. Thank you.
Thank you. Which analysis is more powerful analysis in FUSA? I don't know what powerful means here. Every analysis is mandated by the ISO 26262. Of course, if you have any tailoring argument, then you can avoid some, but more or less, it's impossible to compare. If you limit the question to something like most hazards or risks found in the least amount of time, I would point towards FTA. But is FTA alone sufficient and FMEA not needed? No, you have to perform an FMEA as well. So I think it depends on the very, very specific nature of the question. What kind of, so this is Gopinath's question. What kind of architecture is followed in EV designs? I think again, it's very, very specific to companies. I bet Tesla's following a different one than Tata. So yeah. Is the safety team in companies an independent one? Again, a company's personal prerogative. You could hire safety consultants. You can hire safety engineers in-house. All models are possible. And how technical documents are prepared with respect to V-cycle? depends on the standard you're following. ISO provides detailed guidelines on each document, how it should look like, what it should contain. And so if you're providing a safety work product for a certain analysis, then ISO tells you exactly what all should be included in that specific work product. So Gopinath, if you have a specific analysis in mind, yeah, we can address that as well. Okay, I don't see any more questions in the chat. Does anyone else have any questions? Seems like no, but you can always find me on LinkedIn easily, and you can also use the feedback form. Please, take use of the feedback form, and so that we can tune our next session accordingly to cater to your specific questions. Suraj, Vinayak, up to you.
Yeah. Guys, any more questions? Okay. I
Thank you
think,
very much, everyone, for your
yeah,
time. It was a pleasure getting to know you guys, your work and your questions as well. Have a great weekend, and once again, thanks very much for joining over the Saturday evening. Thank you very
yeah.
much.
Thank you, Priyank. Thank you for this amazing session on functional safety. We look forward to continue sessions, webinars on this functional safety topics.
Yeah,
Thank you.
absolutely.
Thank you, everyone, and have a
Thank you.
great weekend.
Bye.
Thank you. Bye.